Okay, so you're in Fusion 360, and you've got a sketch in which everything is exactly where it needs to be. What is the difference between this sketch and a good sketch? If you're not sure, this is the place for you to be. Whether or not you're that person who has barely modeled their first cube, or you're the guy who can successfully make and 3D print stuff, but every time you need to go back and make an adjustment, everything is just wrong and off, and you tweak one thing and then two other things are broken and you fix those and now something else is wrong, and you just have to dredge through the timeline in order to get everything fixed. This video is for you guys. I want to share with you guys a couple of techniques that I use that help me make models that are not only accurate, but are also really, really easy to change in the future should I need to. So yeah, let's jump right in. This video will be broken up into 3 sections. The first one focuses mostly on sketching. The next one focuses mostly on the basics to Boolean operations. And the last one focuses on some of the different ways that you can make shapes 3D, like revolutions, extrusions, and sweeps. And also kind of takes everything else in the video and just puts it all together. So yeah, let's jump right in. Okay, so before we can get into anything else, let's talk about sketching, because sketching is kind of the fundamental to everything else that we're gonna be doing inside of Fusion 360. And before we get started to how to make it, it's important to understand what it is. So a sketch is pretty much just a 2-dimensional drawing, and that's it. It has no 3-dimensionality to it at all. It literally is a 2D plane that you just sketch something out on. And what we're gonna do with it from there, though, is once you have the sketch, you can tell Fusion 360, like, hey, I want to extrude it up. I want to revolve it around this other shape. I want to, like, actually extrude this out from something else. There's a whole bunch of operations you can do with it that we'll get into in a second. But with that out of the way, let's talk about how to actually make a sketch and what makes a good sketch versus a bad sketch. All we gotta do is hit this button and select the plane that we want to make the sketch in. I'm just gonna do a pretty easy sketch. I think we're gonna start with a cube. And we're gonna make it right here on this plane so that it's flat. And there's a couple of tools that we have available to us while we're sketching. Namely, we have these guys, which are different ways to create shapes. So obviously you can create lines, which are super useful. We could create rectangles and circles and arcs and polygons and all sorts of fun other things. And a lot of these are pretty self-explanatory. So I'm not really gonna get into exactly what is what. We'll get more into lines in a second, but let's just start with a rectangle. And we're gonna start with a center rectangle, because there's actually 3 different ways you can make a rectangle. You can do 2 points if you know that they're diagonal. You can do 3 points if you want to be a little bit more explicit with it. And center rectangle is what we're going to do, which is you pick a center point and then you pick one of the diagonals, and it kind of just fills in the rest for you. So we're going to make, I said we were going to make a cube, so let's make an actual cube. So one of the really big things here is that you'll notice that my cursor is sitting on the bottom leg. And I can actually type in, like, hey, I want this to be 25 millimeters by 25 millimeters. And you can switch between them by hitting tab. Those are the only things you really get to play with when defining a rectangle. So we're gonna click, and that gives us a rectangle. So basically, the idea of a sketch is to create a 2-dimensional draft, you can think of it as, like a rough draft in 2D of what you're actually going to make in 3D. We're gonna hit finish sketch, and we're gonna turn this into an actual cube. Because right now we actually just have a square, not a cube. So we're gonna hit create, and we have a number of different things we can do here to actually turn this 2-dimensional shape into a 3-dimensional shape. And the one we're gonna use is called an extrusion. But going down the list, extrusion basically takes a flat shape and literally just like pulls it up. It's pretty intuitive. A cube is an extruded square, a cylinder is an extruded circle. You can have triangular prisms that are just extruded triangles. You basically just take a shape and actually give it some thickness and call it a day. It's the easiest one, probably the most commonly used one too. Revolution is a little bit more interesting, but as you can see, you basically draft a 2-dimensional cross-section of the thing, and then you're going to revolve it around some axis. So like if you think of a donut would be a circle that you've revolved around an axis that goes through the middle of it. And we'll play with this in a second as well. Sweeping is basically a specialized extrusion, because whereas an extrusion is all about taking a sketch and giving it some fixed amount of thickness in a straight line, a sweep is more about taking a sketch and extruding it such that it follows an existing edge or a curve. And you guys will see what I'm talking about later on in this video, but we're going to use both extrusions and sweeps, and you'll get a feel of like when to use which one. Lofting is also a little bit interesting. You basically give it like, hey, here's the bottom face and here's the top face, and it just kind of smoothly transitions from one thing into the next. And I think that's the biggest thing it's used for, is transitioning between two pieces. Ribbing is exactly what it sounds like. If you have a one-dimensional line, you can give it a little bit of thickness to create like reinforcements for structural integrity. Webbing is what you'll see a lot of times in 3D printing software, where it'll fill inside, like basically it'll fill the gap inside of a volume with some shape. Again, typically I do 3D printing, so I usually leave this up to my slicer, because they are able to make a more educated guess, because it knows what kind of printer you're using, what kind of material you're printing with, all that stuff. But you could totally do it in Fusion 360 as well. Embossing is nice. It's more of like a luxury thing. I've never really made anything functional with it, but it looks really good. And once you like get past like 3D printing things that just work, and you want to 3D print things that work and also look nice, this is a really cool way to give yourself a little bit of flair. Holes and threads. Threads I've used quite a bit, holes I've used less, but both of these basically assume you already have a 3D shape, and then they add a little bit more detail to it, so holes actually just cut a hole out of it. And the threads will give a 3D shape that has like a hole already cut into it. They'll give it a little bit of threading. So yeah, that's a really quick rundown of the different things that we can do. So like I said, we're making a cube. So we're going to be extruding this dude up 25 millimeters. And there we go. That is indeed a cube. We know it's a cube because the sketch was made from a 25 millimeter by 25 millimeter edge, and we extruded it up 25 millimeters as well. So that was easy. Okay, so with that out of the way, let's get into something a little bit more complicated. Let's start off by giving it some legs and then like changing its dimensions so that it's actually more of a table. And normally I would just go model a table directly, but I think this is going to highlight some really important principles of how flexible Fusion 360 is. Anyways, so let's jump right into it. So as I mentioned before, you hit the create sketch button, but now we're not going to be making a sketch off of like this flat face. We're actually going to be making a sketch on the cube face. And there is a subtle difference. So when we make a sketch off of the cube face, the nice thing is that we can actually use the vertices of this square in the sketch, because we've told Fusion 360 like, hey, I am making this sketch anchored to this cube. If the cube moves, the sketch moves with it. On the flip side, if we made it just on the like flat plane in general that we originally made the cube off of, we're telling Fusion 360, hey, I would like to make a sketch that's flat in the XY plane, and Fusion 360 will go, sweet, here you go. And it happens to be on top of the cube, but we haven't told Fusion 360 that the sketch and the cube are actually related. So that's another really big thing that makes sketches good, is make sure they're anchored to the right surface. You might have several surfaces that like happen to coincide. Like in this case, we had the XY plane and the bottom of the cube, but because we know that we're going to be sketching legs onto this cube, we can tell Fusion 360 like, hey, this sketch belongs to the cube and not just the XY plane in general. So let's say that we have like very specific exact dimensions as to where the legs on this cube are going to go. This is where I usually create some lines. So we can use a line, and if we know, hey, the first leg is supposed to be, let's say, 5 millimeters in and 2.5 millimeters up, then we could do something like this, and you can actually click and drag these numbers to put them in a little bit like more convenient location. And so from here, we can grab our circle and give it a center point, and let's give it a radius of, let's just call it 3.5 millimeters. Yeah, that looks about right. Cool. So this is going to be annoying because they're going to be offset, but we can tweak that a little bit. So we now have the one cylinders. There's a couple of ways to get the other remaining cylinders. One of which is with a pattern. We could take this rectangular pattern, and we can actually click on the circle, And then we come over here and it says, hey, it needs to know which directions we're going to create the pattern in. And we're going to create the pattern on that direction and in this other direction. And so from here, we could tell it, hey, we need 3, and the distance is going to be whatever. We could type the distance in here, or we can actually just drag it. And we could say, no, actually I only want 2, but then we can also drag them up and say I need 2 there as well. And that would definitely suffice. We could do that. And the big thing to note here though, and this is where the pattern tool gets a little bit weird, is that we were very specific in the placement of this first one, and that we said, hey, this is going to be a 5mm inlay and 2.5mm up. But all the rest of these are literally just freehanded. Like, we could click and drag them and we could make them look like they're about right. But are they exactly right, or do they just look like they're close enough? But let's see how this plays out with some of Fusion 360's other tools, because looks right versus exactly right a lot of time doesn't come into play. But there's actually a deeper issue here, and it kind of comes back down to the whole anchor point of the sketch thing, because right now this circle is anchored to this corner and the other 3 circles are arbitrarily anchored to the first one. So let's see what happens if we come back and change this cube a little bit, because this is the biggest thing in Fusion 360 for me, is the ability to go back and change the past, right? So we have this box or square, and if we wanted to change its dimensions, we could always click on this dude and extrude it out just a little bit more and do something like that. But we actually have a much more fundamental tool available to us. We have this timeline down here, and a lot of people have seen this and they'll like click and drag it, and it's kind of cool. And at first I thought this was just like an educational tool so that you could, you know, show people how this was made. But it's so much more than that, because if we drag the timeline back to this point, we can actually click on this sketch, and if we double click it, or right click and edit, we can actually edit the sketch right now. And this is huge, because when we edit this sketch, let's say we want to make this a bit longer. So we're going to make this a 25 by 50 and hit finish. Well, now when we drag this forward, hey, look at that. Fusion 360 has actually taken the change that we made in the past and played it forward across all of the events that come after it. And likewise, we could come over to this extrusion and right click edit and basically say, hey, I only want to extrude this up 15mm or 10mm. And we could hit OK. And now if we come forward, you'll notice that the sketch that we just made is a little bit different. And let's actually look at the bottom. But this circle right here is actually still anchored to this lower left-hand corner, which is perfect because that's exactly where it should be. But unfortunately, these other couple of circles are still defined relative to him, so they didn't move with the rest of the shape, which is why I would say that this sketch is certainly less than optimal. There's a better way to do this. And Fusion 360 has done exactly what you've told it to, because you said, hey, I need a circle that is 5mm inset horizontally, 2.5mm inset towards the center, put a circle there, boom, it got the circle, and it got it right. When we changed the sketch, it's still where it should be. But the other 3 circles were defined relative to it because we used a pattern to make them, which is unfortunate, because when the sketch changes, these 3 will always be relative to this first circle and not to the actual body of the sketch. So let's get rid of these 3 guys, and I'm just going to shift click them, and I'm going to right click and hit delete, and they're gone. We don't need them. We're going to define those 3 circles in the exact same way that we defined the first one, and then we're going to go play with the past a little bit, and we're going to see how it reacts. Okay, so we now have the other 3 circles, and they're defined pretty much using the exact same method, where we've got a line that comes in and a line that comes down. So we've now basically told Fusion 360 that the location of these circles is actually relative to the corners of this square. And even more importantly, that all of the circles will always be the same size, and their inset dimensions will also always be the same. So we can hit finish, and if we come back in time to this first one, and we right click edit, and we change this again to be, let's make this one 40 by 30. And again, this is literally just as easy as drag the slider back, right click at it, and then double click any of these dimensions and hit finish. And once again, we can see that the extrusion has actually used the new one. And if we actually look at this new sketch now, all of the circles have resized to be exactly where they should be. And so the really big takeaway here is that Fusion 360 is really powerful because it lets you go back and edit things. If you want to change a shape, you don't have to just change it right now. You can actually go back and redefine how it was originally made. But if you aren't careful with how you set your sketches up, you could shoot yourself in the foot when you do that. And it really just comes down to thinking about what you're actually saying and asking. And yeah, two things might look the same right now, but in the future, if you change your mind about something, are they actually going to stay the same? So that's really huge, I think. But this is a really, really, really good sketch. And the first sketch that we made, although it used to be visually the same, was a really, really, really bad sketch because it doesn't properly convey the same amount of information. So yeah, those are the things that I look for when I'm talking about like making a good sketch. So let's talk about the Boolean operators now, because we have the circles for where we want the legs of this table to be, but they're not legs, they're literally just circles right now. Okay, so let's talk about how to actually make these into legs. We're gonna start by clicking the extrude button, and then it's literally just as simple as clicking all four of these dudes and punching in how tall we want this to be. So let's just say we want them to be 50 millimeters tall. Oh, that's actually quite large. Okay, let's bring that down substantially to like 30. Nope, let's bring that down to like 10. 10 works, okay, cool. So we've got this little baby table now. And we've got the four of these dudes, and if we actually come over here and look, Fusion 360 has implicitly made them part of the same body. And that's pretty cool. So let's talk about what Fusion 360 did behind the scenes for us so that you guys know what's going on and you can do it for yourselves if you need to. So we're gonna come back and we're going to edit this extrusion. Now, one of the really big things here is you notice this operation here that says join. This basically says, hey, any body that these dudes touch, they're going to be joined to it. We could change this to cut, or we could change this to intersect. So join basically says when two shapes are joined, they become one shape. You're taking, think of it as the Venn diagram. It's everything in the left side and everything in the right side, and you're good. You get the sum total of everything. Cut would basically be only the right or left side of the Venn diagram. So hey, I'm going to model this, but this is actually modeling negative space. So I'd like to subtract this out of the first shape. I want to cut it out of the first shape. So this would, again, be like the left or the right side of the Venn diagram. An intersect is basically the middle of the Venn diagram where you're saying, hey, I only want to keep what's both in this shape and in the other shape that I just made. So in this case, join makes sense. And the nice thing, again, is when you extrude or revolve or do a lot of these shapes, they'll actually give you the ability to perform this operation like as part of the extrusion. But let's change this to new body, because this is going to tell Fusion 360 like, hey, don't perform any Boolean combinations, just make a new body. And we're going to hit OK. And now we have all of these different bodies separately. So what do we do if, let's say, we modeled these separately and now we want to join them after the fact? Well, thankfully, it's pretty much as simple as coming over here and hitting combine, and then you select a target body and the tool bodies. Now, again, when you're joining things, it's tempting just to not care which one's the target and which one's the tools, but there is actually a difference, because in all of these, the target body is going to be the one that's left after we do the combination. So let's say that this dude is actually called table. And the rest of these are just going to be the legs. When we hit combine, if we grab a target body at random and just grab everything else as the tool bodies and hit join, you'll notice that we're left with body 6 and we're not left with table. And this is because body 6 was the target. So if we undo that and hit combine again, and we make sure to grab the table as body 3, I don't know why it undid the rename. And if we come back and we hit combine and we actually grab the table as the target body, and we grab all of the legs as the tools, when we hit OK, we are actually left with table, which is pretty cool. So let's talk about what happens when we want to, let's say, put an indent into the middle of this table. So we're gonna come over here and we're gonna create a sphere. And again, because we explicitly want a sphere, it's totally okay to not make this as a sketch. And again, Fusion 360 is going to ask us, hey, which plane do we want to make this on? And let's put our indentation here, and we'll build on this in a second. But let's grab that dude as our first point. And again, operation is just gonna be new body. And we're gonna make this a 2mm sphere. And then we're gonna come over to combine, and we're gonna say that the table is the target, and that the tool body is gonna be the sphere. And let's see what this looks like. So if we do a join, we are left with one body that contains both the table and the sphere. If we do a cut, we are left with the table that has part of the sphere cut out of it. And if we do an intersect, we're left with half of a sphere because that is basically where the table and the sphere overlapped. So let's change this to a cut, and we'll hit OK, and we now have a sphere cut out of our table. And if we want to make this a little bit decorative, before we did that, we can actually drag the slider back and click on the sphere, and let's give it a pattern. So we can click on the object, and then the direction that we want to pattern is going to be this dude, and we can take our sphere and move him all the way down to the end. And if we pattern it, that looks about right. And we can tell it how many of these dudes we want, and we're just gonna stack a whole bunch of them up because it's supposed to look decorative. And yeah, that looks good, so we can hit OK. So now we've got a whole bunch of these spheres. And if we play this forward, Fusion 360 still only cut out the first one because that was all it was supposed to do when we made it. So we can come back over here and hit Edit Feature, and we can add as many target bodies as we want. So we could just come down here and pretty much shift click the entire set to mark them all as target bodies and hit OK. And now all of the spheres have been cut out of the table. So that pattern is really useful to just make the same object and literally repeat it in a couple of different ways. And if we notice, there's a few different types of patterns. We have rectangular patterns, which are nice because you can select 1 or 2 axes and repeat it along both. And if you select 2 axes, you kind of get like this grid of shapes. And if you select 1, you obviously just get a whole bunch of them in a line. The circular pattern is nice because you basically give it a center point and it repeats it as many times as you want around that center point. This is super useful for making like teeth on gears and stuff like that. And then pattern on path is, again, if you have like an arbitrary path and you just want to make a whole bunch of them along it, then that's great. So the nice thing about the pattern here was the same thing as the patterns in the 2D sketch, in that we basically just copied the shape and repeated it a whole bunch of times. We didn't have to make any like framework to work around. We didn't have to make sketches that define where these things are at. And in 3D space, the pattern actually works a whole lot better than it did in the 2D space. Probably because instead of copying an element that's anchored, we defined the sphere in this plane, and the pattern was also defined on this edge, which means that as we come over here, and if we make the table even longer still, so we'll go from 40 to 80, literally just gonna straight up double it, the spheres actually stay relatively centered, which actually is a logical thing for them to do. So the patterns in 3-dimensional space and patterns on sketches that aren't anchored to something typically work better than patterns that are specifically anchored to something. Okay, so let's talk about a couple of the different ways that we can create different shapes. Let's say that we wanted to actually put like a nice bottom edge around this table. I think the easiest way to do that is to create sketch. And again, we're going to make a sketch off of this plane. And let's just define a little triangle that kind of comes off of the bottom. We'll just do like 1.5 millimeters that way. We'll come up to be, let's do like 3 millimeters tall, and connect that dude to make our triangle. We can hit finish, and nice, there is our triangle. If we want to actually take this triangle and make it as long as this sketch, probably the easiest way to do this is to hit extrude. We can click on the triangle and then click on this face. And if we hit OK, we end up with a triangle that perfectly goes from that face to this face. And yeah, it just works great. But another way to do this, as I mentioned, is to come over here to create, and we can hit sweep. And if we select the triangle, then instead of selecting this face, we can actually select this edge. And when we select the edge, we kind of get the same result, but we didn't have to tell Fusion 360 this time, like, hey, I want to go from this face to this face. But the important thing here is that the triangle is now anchored to that edge. If the edge gets longer, then the sweep will like get longer to match it. As opposed to, again, if we hit extrude and we click this, when we click that edge, yes, it goes all the way to the edge, but if you look, Fusion 360 is actually just taking the distance between these two edges and putting it in the box for us. So if we hit OK, and then we come back and change the sketch so that those faces are now, let's say 30, and we have a square again, and we hit finish, we now have this ugly edge because the triangle is set to just be extruded 40 millimeters. But if we come back and we define this instead as a sweep, again, the nice thing about sweeping is that you select profiles and you select a path, and it sweeps it along the entire path. So now this triangle isn't just a hard-coded 40 millimeters long. This triangle is set to be as long as that edge is. And if we come back to this original sketch and we change this down to 30 and we hit finish, we can see that this triangle actually like adjusted to match, which is, again, like super awesome. It's two ways to visually do the same thing, but this way carries more information. So again, like one of the key differences is that sweep doesn't have to be in a straight line, but sweeping also is along an entire edge or a fraction of the edge, as opposed to extrusion, which is just a hard-coded 40 millimeters, 20 millimeters, whatever. I think one of the big key takeaways of this video is that anytime you can define what you're doing now in terms of something you've done in the past, you're going to end up with a project that's a lot more scalable. Because if you go back in time and change what you originally had, everything just lines up. As opposed to like, hey, I put all these hodgepodge of things together, and yeah, they visually look the same right now, but hey, if I go make the table smaller, then the feet don't adjust properly, and the trim on the table is just totally janky and off the sides, and it's all just completely messed up. Like, no, we now have a table that works great. So just to drive that point home, let's go make trim along the other sides. We can actually come over here to sketches and unhide the one we had about this face, which is this triangle right here. So let's talk about how to make this bend around that corner. Probably the easiest way to do this is with the revolution. So we can hit revolution and we click on the triangle as the profile, and then we have to select an axis. And we know that we want to sweep along this axis. And we can specifically say, like, if you notice, it's defaulting to 360 degrees and it wants to cut. But we can say, no, I want this to be a join and I want this to only be 90 degrees. So yeah, we now have this wonderful triangle here. And again, we can select the face of this guy. Notice how this doesn't even have to be a sketch. We can select the face of this guy. And again, come over here and hit sweep along that edge and hit join. And we'll just repeat it another 2 times. So grab, oh, hang on. Here is a slight problem we've run into, is we no longer have the triangle as a sketch here, and because we joined the last operation, we don't have it as a separate face. So here's where we're actually gonna want to do this sweep and hit edit, and instead of automatically joining it, we'll sweep it into a new body and join it later. So now we have this as a separate face, and we can revolve it, again, around this axis. Again, it'll be 90 degrees. We can sweep this guy along this path. So we've run ourselves into another quick corner where if we sweep this dude along this path, notice how it's going to sweep along the entire path because once again, we've already joined this dude to the table. So let's hit cancel and let's go back in time and fix this problem. So I think that first sweep is where the problem is. So we can click on this sweep and we can hit edit. We can come down here and say, hey, sweep to new body and hit go. So that sweep is to a new body, but now this revolve isn't to a new body. So we have to come back here and set the operation to new body again, and everything after that should be to new bodies. Nice, so now they're separate again. which means that we are now free to once again sweep this triangle along this path. And notice how it's not the entire path again. And now we can revolve the triangle once again along that axis, 90 degrees, into a new body, and hit OK. So now we have a table that has all of this lovely trim to it. And the trim is really, really well defined, and so we are free to pretty much take all of these bodies and join them together. So I'm going to click on this dude and hit combine, because whatever you initially click on defaults to being the target. And then I'm going to select all of the rest of the tool bodies, and I'm going to mark it as a join, hit OK, and we now have this wonderful little table. And again, the really fantastic part is because we didn't just go run through and define these as extrusions, because we actually defined these as sweeps in terms of the edges that the table already has, we can come over here and hit edit sketch, and we can just completely change the dimensions and aspect ratio and all of the properties of this table. So make this 25 by 50 again. And if we hit finish, look at that. We have this wonderful trim that just follows the table. We can actually come over here and do something even cooler. We can come back to this sketch and hit edit, and we can redefine the actual dimensions of the trim itself. So we can say, hey, the trim should only be like 1 millimeter by 1 millimeter. All right, we just want to make it a nice small little trim at the bottom. And if we hit finish, boom, the entire trim of the entire table has been adjusted to match the new specification, because everything was defined in terms of everything that came before it. So yeah, to bring this video full circle, the difference between the accurate model that we started with and the good model that we have now is how it responds to change. We started off with a model for the table that as soon as you changed it, the legs were in the wrong spot, the trim was off the edge of the table or didn't even make it to the end of the table, and it was all just wrong. And now we have a table that as you change it, everything just responds and lays out perfectly, because everything is defined in exactly one spot. If you want to change the trim, there's one sketch you change. If you change the dimensions of the table, the legs and the trim and everything just reacts to that change. And that, to me, is the difference between a good model and an accurate model. So yeah, I hope you guys enjoyed it, and I hope you guys learned something. And if you did, definitely drop a like on this video and check out everything else I've got here. There's not much in the way of tutorials, but if you guys like this, I'd love to make more. And there is plenty of other content here. I'm not going to say that it's good content, but it's definitely content. So yeah, if you want to interact with me a little bit more, as always, my Twitch is in the description, and I'd love to see you guys there. So yeah, until next time, I hope you guys have a good one, and yeah. That's it.